In January 2023, only 2 months after its launch, ChatGPT made history by becoming the fastest growing app of all time, reaching 100 million users. Capable of writing entire articles, generating software code, and aiding students in learning about virtually any topic, ChatGPT marked the onset of an explosive growth in generative AI, the technology powering it. This surge wasn't just confined to creating text and code. It extended to generating highly realistic images, videos, 3D, voice, music, and more. According to a report by McKinsey, generative AI holds the potential to contribute somewhere between $2.6 to $4.4 trillion annually across 63 different use cases. Today, thousands of organizations leverage large language models to transform their business, using them for tasks like automating customer operations, crafting marketing content, or even assisting their software engineers write code 56% faster. The possibilities seem endless. Welcome to the third episode of AI for Business, where we decode AI and how to use it in your day-to-day work for the non-AI experts. In the previous episodes, we got introduced into AI machine learning and explored more than 50 practical use cases. In this episode, our focus is going to be on the rising star, generative AI. We're going to explore more than 30 different use cases across different domains. From smart knowledge retrieval and chatting with enterprise data, to co-pilots and autonomous agents, to a lot of other applications in health, education, finance, retail, marketing, and more, you'll get introduced to the major patterns and types of use cases in this growing field. This will help you understand how to apply generative AI into your day-to-day work. If you want to understand what generative AI is and how it distinguishes from other types of AI, I highly recommend you revisit the first episode of this course as it delves deeper into this differentiation. A big disclaimer before we start. Generative AI is moving so fast. The use cases you're going to hear about today are somehow relevant as of the time we record this video, which is the end of September 2023. But I really encourage you to keep an eye on this growing field because it changes literally every single day. With that said, let's dive right in. First of all, I want to start with the fact that large language models are capable of generating stuff beyond text. People might be familiar with the different applications of ChatGPT in writing articles and summarizing text and so forth. But large language models are very powerful in producing different types of data today. Tools like GitHub Copilot, Amazon Code Whisperer, and Meta's Code Llama are able to assist software engineers drastically in writing software code, writing unit tests, finding bugs in software, and more. In the visual realm, we have a lot of tools today that are able to generate highly realistic and beautiful images from text inputs. These include tools like Stable Diffusion, OpenAI's DALL-E, Midjourney, and more. Companies like Runway are making significant strides in the video generation space, where you can type specific prompts and get video output. Musical creativity has not been left behind either. With tools like Stable Audio from Stability AI, we can see how AI could be used to produce really nice music. Let's listen to some samples. Now that we have seen the different types of data that Gen AI could produce, let's explore where the real economic value lies and uncover the significant use cases where companies are reaping the benefits of this amazing technology today. Let's start with this chart from the same McKinsey report that highlights specific sectors with the most substantial economic impact. Glancing at the chart, you'll observe the vertical scale representing impact in billions, while the horizontal scale illustrates impact as a percentage of functional spend. The graph highlights promising domains such as sales, marketing, software engineering, customer operations, and product R&D. Areas I personally concur hold immense potential. In addition to those, I'd like to add another pattern that has been tremendously helping companies recently: knowledge retrieval. Generative AI, with its ability to understand natural language, can help different organizations access their data through natural language. Employees can ask questions and chat with their enterprise data, whether they have documents, PDFs, presentations, knowledge bases, product features, you name it. Now you can ask those questions simply in natural language, and generative AI and large language models will be able to retrieve that information. More on this later. We're going to expand on it, give a lot of examples, but I just wanted to add this as a major pattern to the previous patterns that we just discussed. A great example to start with these out-of-the-box tools that anyone could use, is the suite of tools that Microsoft has created for the Office 365 Copilot. Let's take an example. Here you're asking it, for example, to create a presentation based on some proposal document. You're attaching the document, and boom, it created the presentation from scratch. Wow, isn't this amazing? Now you can keep adjusting the presentation, like, for example, hey, add a cost-benefit analysis, and it would add this for you. And then you can go on and add some visuals, for example, again, through simple natural language prompts. Boom. Now imagine how this would transform presentation creation, right? Now let's take another example with spreadsheets. Here, for example, we have a spreadsheet with transactional sales data. We have different dimensions like countries, customers, products, etc. You want to do some analysis. So we got on ask, hey, analyze this quarter's business results and summarize key trends. And then it would do that, right? And then you can go on and, hey, show me a breakdown of some sales growth, and it would show you this. You can keep on adding these questions, adding visualizations, extracting insights, adding charts. And, these things historically used to take a lot of time, a lot of effort, writing different equations and stuff. Here you would go to what if analysis, like what happens if this and this happens, and it would provide the scenario, and then you would build a model and so forth. Now let's transition to another example in Word, when you're writing documents, for example, writing first drafts. Writing proposals is one of the most tedious tasks that takes a lot of time. Let's see what you can do with Office 365 in that case. You can ask it simply to write a proposal based on some meeting notes and a product roadmap document, and it would go and do that. These things, by the way, is so helpful in generating first drafts that you can iterate on. Don't take it, as the final version or something. And then you can start iterating, asking it, or hey, make it look like this style. You can convert the style to make it mimic something and pull images from some other presentation, and it goes on and does that, and so forth. You can add a summary at the beginning and keep on doing things. How would that transform writing in general and, enterprise documents in specific? For those interested in data analysis, but may not be experts in coding or sophisticated software, ChatGPT's advanced data analysis is a game changer. It enables you to analyze complicated data sets using natural language. You can upload whatever files you want, like images, spreadsheets, text documents, or whatever data files, and run queries using natural language, ask questions, and generate insights. It can clean and manipulate data with just simple instructions in plain language, and also provides data visualization capabilities, enabling you to see your data in charts and graphs without needing to create them manually. In marketing, many companies are using generative AI today to bring massive amounts of automation to a wide array of tasks, including crafting marketing copy, generating engaging social media content, writing personalized outreach emails, and even producing a diverse range of visual elements. It's not just about streamlining the process, but actually enriching the content and bringing a whole new level of personalization. Let's explore a real-world example, Typeface, a company using generative AI to revolutionize content creation for marketing. A classical use case is creating nice images for products. So for example, you can select a product, write a simple prompt describing what you want to see in the image of the product, and boom, you end up with a bunch of nice photos with nice backgrounds that are on-brand and enterprise safe. And the next step, you might want to take these images and create some marketing campaigns with them. Let's see how that's going to happen. You can go on, select a template for an Instagram ad, and start filling some attributes like the goal of the post, which product are you showcasing, your target audience, the tone you want to use, and so forth. And it's going to generate the campaign for you. You have a nice image with a nice description that you can take right away and put on social media. Now imagine the amount of automation you can bring to social media with a technology like this on various social platforms like Instagram, LinkedIn, Facebook, and more. Applications in other domains include the following. When you look at the area of software in general, you have code generation For accelerating application development, you have application prototype and design to quickly generate user interface designs. You have things like dataset generation, generating synthetic data to train machine learning models. In the area of audio, you can think of things like text-to-voice generation for creating educational voiceover, sound creation, which could be used for making custom sounds without copyright violations, audio editing for editing podcasts in post without having to re-record. In the 3D world, you can look at applications like 3D object generation, which could be used for video games, digital representation, and creating interior design mockups and virtual staging for architecture design. In video, there are a lot of applications like video creation, which could be used in entertainment, like generating short form videos for social media, for example, or training or learning. And there is also voice translation and adjustments, which could be used for video dubbing, live translation, and voice cloning. For most of these use cases, there are existing tools that you can subscribe to, write a simple prompt, and start generating the output that you want, whether it's a video, an image, code, or whatever. Now, I want to shift gears to talk with you about the second level of using generative AI, which I call it the enterprise generative AI systems. That's where we can start seeing how generative AI could be used in an enterprise setting for enterprise use cases in a little more sophisticated way, but brings, generally speaking, more value. Let's see it. Enterprise generative AI is mostly about using foundational models with your enterprise data. This data is not usually published on the web. For example, let's say you would like to have a smart chatbot that you'd like your customers to have intuitive conversations with, to ask questions about your products or services, facilitate returns, make bookings, and so forth. That bot will require to have access to your latest data about those customers, those products, the purchasing history, and so forth, right? Or if you'd like to have an internal chatbot where your teams could collaborate and ask questions about company-specific information, like, again, specific aspects related to products or services, historical proposals you have sent to a client, company proprietary data, and so forth. Again, that bot would require to have access to large amounts of your company's data. Now, in these cases, you would like these models to have a deeper level of integration with your company's data, and that data could exist in many unstructured forms like documents, emails, spreadsheets, historical Slack conversations, presentations, and so forth. There are two major ways for having these models generate content based on your proprietary data. Those are fine-tuning and retrieval augmented generation. I'm not going to go through the technical details of each right now. You can look this up on the internet, a lot of great resources, but I'd like to provide a gentle introduction and some tips on when to consider each method. Fine-tuning involves refining a pre-trained large language model on a smaller specific data set to customize it for unique needs. This method, while impactful, is resource-intensive, necessitating significant compute power, infrastructure, and deep AI expertise. RAG, or Retrieval Augmented Generation, on the other side, enables large language models to access the latest proprietary knowledge without the hurdles of model fine-tuning. It enhances the quality of responses by grounding large language models on external, up-to-date, and verifiable knowledge sources, thereby reducing hallucinations or misinformation. Fine-tuning is usually helpful when you'd like the model to have a certain style or tone with the output it generates, or a specific format, like code generation, for example, or when you'd like the model to have a deep understanding for the specific words used in a specific domain, right? RAG, on the other side, is pretty helpful when you'd like the model to be able to reply based on the latest data that you have, like latest customer data, latest products data, services data, stuff like that. So whenever you need this kind of recency in the kind of replies the model generates, RAG is the way to go. There is no such thing that one is better than the other. It's just about what are you trying to achieve. In the following part of the video, I'm going to show some examples for retrieval augmented generation that would help showcase how it could be used in an enterprise setting. So as discussed before, the whole idea about RAG is to enable large language models to generate the replies based on specific data sets that you'd like to use to ground the answers of these models. In this case, this is a demo built by Microsoft using the ChatGPT model on Azure OpenAI. And what they're doing is they want to create a chat experience where the employees of a fictitious company called Contoso can chat with internal health insurance documents. This is, as you can see, this is the health insurance policy consisting of about like 103 pages. The traditional way of looking for information inside that document would take a lot of time for anyone to understand the specifics about their policy and whatnot. So here, they are enabling a chat experience. As you can see, you can go on and start chatting, like asking, for example, what is included in my Northwind Health Plus plan that is not in standard? And boom, it generates the answer. As you can see, Northwind Health Plus offers more comprehensive coverage than Northwind Standard, and so forth. The thing here is that you can find the citations. These are the sources where this answer was generated based upon. You can click on any of these citations and see the source part or piece in the document that actually was used to generate this reply. This brings a lot of credibility. One thing common about large language models is hallucination, producing replies that might not be factual. So seeing those citations and being able to track where exactly they are in the document actually somehow solved this problem. And then the workflow goes on. The person is asking a follow-up question. Does my plan cover eye exams? The model understands that they are referring to the plan that they've asked about before, so there is no need to explain things again. And then the answer, as you can see, yes, Northwind Health Plus offers coverage for vision, etc., etc. And the same thing, you have citations. Imagine if we can apply the same methodology over whatever set of unstructured data that you have, whether, again, this is found in presentations, documents, PDFs, emails, etc. RAG is widely used by many companies and organizations today to enable easy access to proprietary data through natural language interface, very similar to what you see in ChatGPT. Now, let's see a similar example, but this time it's more for consumers in the e-commerce space. Let's have a look. So in that case, it's an e-commerce store for, again, the fictitious company Contoso, and someone is asking, give me some information about your hiking jackets. So it goes and retrieves some information about the hiking jackets, but it takes into consideration what's available in the shopping cart for that customer right now. We have 3 products, so the reply is grounded and is related to those 3 products, as you can see here, and it provides some suggestions and recommendations based on what's available in that shopping cart. That's a quick example for how retrieval augmented generation could work in the case of e-commerce as well. By now, I'm sure you're starting to notice the pattern here. The emergence of natural language interfaces. This ability for users to just talk with software instead of going through graphical user interface or different modules. This ability is enabled by generative AI, and this is opening a whole set of possibilities for consumers, businesses, employees, and individuals to interact with software in an incredibly natural way using language. I want to show you a set of examples for early adopters who are starting to embrace this idea of natural language interfaces in legal, travel, health, online shopping, and more. Let's have a look. In the education space, Duolingo, a famous language learning app, has used GPT-4 to enable 2 major features. One is Explain My Answer, which explain in details the mistakes that you have done while using the app, for example. So you can ask it like, hey, what was the mistake? And, ask it to elaborate again, please. And it's going to provide details, helping you to understand why that was a mistake. The other feature is role play, where you can imagine different scenarios, like here, for example, engaging with a waiter in a restaurant, asking for your order and stuff like that, through which you can learn specific languages like Spanish or French. Isn't that beautiful? Another beautiful example that I like is what Instacart did with its new feature, Ask Instacart, that is enabled by GPT-4. Users can go and start chatting with the application. For example, you want something related to lunch, you can type it, and then a set of questions would come up, and you can pick up a question like, what's a healthy lunch for my kids? And then the app would understand that, go and retrieve some products related to this, like healthy lunches for kids, provide some tips, brings the related products, and then you can follow up with other questions like, what are some healthy snacks for my kids? And go on and ask questions and, pick items. Isn't this totally transforming the shopping experience? In the legal and contractual space, I like what DocuSign showed before, bringing generative AI to the contract space, like summarizing the most important aspects in a contract, for example, and extracting the specific items that you're interested at. Another thing is chatting with the contracts, right? Like asking questions like, hey, will this contract be automatically renewed? Or what is the payment due date? Or what is going to happen in the event of act of God, etc., etc. You can ask these questions. Generative AI is going to go retrieve the answer and come back instead of you searching manually for these insights. In the health space, Amazon created a service called AWS Health Scribe, which is able to transcribe voice conversations between the health professionals and patients and extract meaningful insights. Like in that case, for example, as you see here, it's able to A, highlight who's the speaker, B, extract key items like the chief complaint, history, the plan, and so forth, which can totally automate the idea of writing clinical reports, summarizing these reports, and extracting meaningful insights from health conversations. Google has shown some interesting work as well using MedPalm 2, which is a large language model optimized and fine-tuned on health data, where, for example, you can pass multimodal data. In that case, it's like an X-ray and, question, what does this film show? And then, the model would process these two inputs and come up with an answer. Of course, these insights and answers when it comes to health need to be taken with a grain of salt and, with high care to accuracy and stuff like that. But again, it's a very nice step in the health space. In the travel space, imagine if travelers can chat with an app like Expedia, speak up their mind, what their preferences are, and the app would help them plan their trips. In this example, Expedia is showing an example of someone planning their honeymoon. So they go on, launch the app, and start chatting. Hey, I'm going to Hawaii for my honeymoon, etc., etc., and then start exchanging conversation with the app, right? So next step, that person is gonna start, asking some questions. Is April a good month for surfing? Getting some tips and tricks about the duration, and then starting to ask for some recommendations for a couple of romantic resorts in Maui. And the app would return this based on the data. This is definitely using retrieval augmented generation here, as we discussed before, and then moving forward until you book your trips. Wouldn't that be fantastic if you, instead of going through a lot of comparisons, you can just share your preferences with an app, see the insights, and book directly through natural language? Another interesting paradigm leveraging large language models is autonomous AI agents. Although not widely adopted in production yet, there are increasing indications of their massive potential and promise in the field. Agents like AutoGPT and Baby AGI exemplify how complicated tasks could be broken down into smaller chunks and tackled step by step with the help of large language models. Here is how agents generally work. Once they receive the big objective from the user prompt, like build a website, or order pizza, or build me that game, for example, or whatever, they start dividing that objective into subtasks, and each subtask could be further divided into another subtask. Now, these subtasks get allocated to agents who are employing large language models for reasoning and to execute these actions on their own. Now, these agents, to achieve these subtasks, they can use tools. These tools range from, for example, search engines to look up something on the internet and come back, or leveraging or integrating with APIs from other systems, or other things. Now, once the subtask is achieved, it rolls back, and once the big objective is achieved, the loop ends. That's in a nutshell how these agents work. You can start seeing that this somehow showcases the ability of these agents to autonomously execute complicated tasks in the future. Let's take an example, Meta GPT. Imagine you have a team of software experts who can build whatever app you have in mind with a simple, brief description. Well, that's more or less what Meta GPT does. It's a multi-agent framework which can take a single line prompt, a description of like, hey, I need to build that game or that website or whatever, and turns it into a comprehensive set of outputs that are required to build that solution. For example, requirement documents, user stories, data structures, APIs, code, project description, competitive analysis, you name it. So how exactly does it do that? Well, again, it's a multi-agent framework and it has multiple roles inside it. For example, project manager who can put together a project plan and review the progress and so forth. A product manager who can come up with the requirements needed for that product. Software engineers who can write code and execute that code. QA testers who can write unit tests and execute those tests, and so forth. Each of these agents do they do whatever it takes to complete that project. Let's take an example of seeing MetaGPT building a game called 2048 from the paper that the authors put for that framework. Let's have a look. So it all starts with the human input. As you can see here, the user starts with, hey, make the 2048 sliding tile game. This is the seed from which the whole project grows. And then comes the product manager agent's role. Acting as the project's visionary, MetaGPT's product manager agent takes your idea and crafts a product requirements document detailing what the game should do and how it will hook players. And then passing this to the architect agent. With a plan in hand, the architect agent steps in to design the game's technical structure, deciding on the tools, like Pygame in that case, and how the components fit together. And then comes the engineer agent's role. Next, the engineer agent rolls up its sleeves and starts coding based on the architect's design, building the game mechanics and user interface piece by piece. Finally, the QA engineer agent meticulously tests the game, ensuring everything works as intended and the game is ready for hours of fun. Another example is ordering food on DoorDash through agents. This is an app called Multion. User can type what they're looking for, like ordering a burger from The Melt in Palo Alto, and it goes on and starts searching the web for that info. It finds The Melt DoorDash, it goes to the page, and it starts, clicking on the link to that page and, clicking the Melt Burger item, adding it to the cart, proceeding to checkout, and it does all these actions on the website. And then finally, it executes the order, and voila. Another interesting use case by Adept AI Labs, they built a model called Action Transformer, ACT1 for short, and that model can basically help you find a suitable house through natural language instructions, right? Let's see it in action. You can go and say, find me a house in Houston that works for a family of 4, my budget is $600K, and boom, it goes to the website, starts searching, entering the criteria. For example, based on the requirements, the max budget would be $600K. Beds would be 4 or 5 plus, and there you go. The final application I want to show using the same model from Adept AI is this one. This is dealing with Salesforce. If you have been using CRM or like Salesforce or others, you know that there are usually multiple steps involved when you're, registering leads or, taking memos on or notes on some clients and stuff like that. Now, using natural language, you can do cool stuff like this one. For example, add Max Nye at Adept as a new lead. So it goes on, opens the needed modules, start adding the information, update it, save the information, and voila. Log a call with James Veal saying that he's thinking about buying 100 widgets. Same thing. The agent would go on, open the needed modules, open the profile, update James Veal information, add the note, and that's it. To summarize, generative AI is truly transforming the world. It's absolutely gonna change every single domain moving forward. You could be part of this. Your company could be part of it. And that's exactly why I created that course, to help everyone understand what the heck is going on in the AI space, and most importantly, be able to act on it. If you enjoyed this episode, I appreciate if you can share it with others who could enjoy it too. And now, after we have seen so many use cases for classical AI and generative AI, it's time to take our first steps towards applying this knowledge. In the next episode, we're going to see how can we start selecting the best AI projects for your company and evaluate these projects based on multiple criteria. With that said, thank you so much for your time today, and see you in the next one.